Hello, I'm talking to you. This is Goddess of Science Physics, and I'm Mrs. Bolden, and I'm going to go over the speed and velocity problems for practice that you had for homework. Okay, so let's get to it. Calculate the average velocity in meters per second. So I always write down, as I go through these, I don't know what the velocity is. That tells me I know that I'm going to have velocity in the formula. So I put a question mark because I don't know. In meters per second, which is okay, great. Make note of that. We'll underline that. Of an ostrich that runs 800 meters, so that's a distance, equals 800 meters to the north. And we may or may not need that direction, but since it's given in the problem, it might be of use later. And then the time is 12 seconds. So we need a formula that has V, D, and T in it. So that would be V equals D divided by T. And so now that we have the formula, let's substitute those numbers in the formula in the right spots. So V equals 800 divided by 12. And when you do the math, you get 66.67 meters per second. And because we're looking for a velocity here, we need to have a direction. So I guess we did need that direction there, north. Now, make sure that you round appropriately. I'm not interested in 73 places after the decimal point. I'm really only interested in 2. So round appropriately, 2 non-zero numbers after the decimal point. So this answer was actually 66.666666, and so forth and so on. So I want 2 non-zero numbers. So this is 1 non-zero number. This is 2. So we have to look at this one to see what to do with that one. And because it's a 6 or greater, it's a 5 or greater, you need to round up that this next door neighbor 6. So make sure, even though you're doing, that's kind of a mathy thing, we need to round appropriately in this class. So bring that skill across the hall from the math department and apply it to physics. Okay, next one is, hold on while I reposition my camera here. Oop, hello, there we go. So calculate the average speed. So we're looking for speed this time. Whoop, got something under my paper here. So that's what we're looking for in meters per second. Good to know. Of Mario, who runs up the 4-meter ramp. So that's a distance equals 4 meters to save Princess Peach. It takes him 5 seconds, and that's a time. So our formula needs to have S, D, and T, and very similar to the velocity formula because they really are kind of the same thing, except when you have a velocity, you have to have a direction on it. So let's plug into this formula. S equals 4 divided by 5. 4/5 is 0.8, and the unit it tells us we need to use is meters per second. Do we need a direction? Nope, because we're doing speed here, and speed is not a vector quantity. Next problem. So calculate the distance in meters. So we're looking for distance that Mario runs if he maintains the average speed you calculated in part A. Well, what was that speed? Speed equals 0.8 meters per second. In part A for 60 seconds, and that's a time. So we have S equals D over T. Plugging in here, we got 0.8 equals distance, which we don't know, so we'll just leave that as a D, time divided by 60. So there's a couple of ways you can solve this. Probably the easiest and least confusing way is to just put a 1 underneath here. If you do that, it doesn't actually change this value at all, because you can divide by 1 a million times and it won't matter. It's still going to be that same number. But what it does for us is we can do something called either cross multiplication or means extremes. So if you multiply these two things together, you can make them equal to these two things multiplied together. So you get 0.8 times 60 equals 1 times d, or just d. Multiplying those two things together, you end up with 48 meters. Okay, so that's the first two, but it's actually three. So then, going to the next thing here, got to readjust the camera. So calculate the time in seconds. So this time we're looking for time. Slide that over just a hair. So we're looking for time. That it will take a car, and we want to have our answer in seconds, car to travel a distance of 3,500 meters if its velocity is 25 meters per second north. Now, we may not need that direction, but at least we know what it is, and we won't have to go back and read the problem again. So we're going to use the velocity equals distance over time. Plug into that formula what we know. So we got 25 equals, whoops, over here I made a mistake. It's not, there aren't two T's, one's a D. So it's 3,500 divided by the time. So we can kind of do the same kind of thing that we did last time, just put a 1 underneath here, multiply those two things together, so you end up with 25t equals these two things multiplied together, so 3,500. So to get rid of to get the t by itself, we're going to divide both sides by 25. And when we do that, we get a number, which is on my other sheet of answers, a number which is 140 seconds. Okay, that takes care of that one. Next one, calculate the distance. So we're looking for distance. A bicycle will travel in 12.5 seconds, so that's a time. If its speed equals 9.4 meters per second. So we're going to use the speed equals distance over time formula. Speed is 9.4 equals distance, which is what we're looking for, divided by 12.5. Again, we're going to put the 1 underneath there, multiply these two things together, make it equal these two things multiplied together. So we got 9.4 times 12.5 equals d times 1, or just d. Multiplying those two together, you end up with 117.5. And we're looking for a distance here, but it doesn't tell us what unit to use. If it doesn't tell you, you have to look at the speed unit. Whatever the distance part of the speed unit is, that's what your distance is going to be. Okay, so it's 117.5 meters. The last two problems, we need to calculate the velocity, so we're looking for velocity of a skateboarder who travels 32.9 meters west, and that's a distance, equals 32.9 meters west. Okay, don't know if we're going to need that west, but I assume since we're calculating velocity, we probably will. And the time that he travels that distance is 7 seconds. So velocity equals distance over time. And so we have velocity equals 32.9. This is very awkward the way I'm writing. Got my arm up in the air trying to write here. And when you divide those two out, you end up with 4.7 meters per second. And because it's a velocity, we do in fact need that direction, and that would be west. Last problem, calculate the time. We're looking for time here. That takes a horseshoe to travel 10.3 meters, so that's a distance. If it's thrown with a velocity of 3.1 meters per second west. May not need that direction, but let's write it down just in case. So we've got velocity equals distance divided by time. We have 3.1 equals 10.3 divided by time. And hold on just a second, I'm going to move my thing up so I have a little bit more room to maneuver my arm here while I'm making this video. So we're going to put the 1 here, multiply these two things together, so you get 3.1 t, and make it equal those two things multiplied together, which is 10.3. Now we're just going to divide by 3.1, and you end up with 3.32, and we need to know time, and we're going to look at our velocity unit, and the time that unit that's part of that is seconds, so that's what our unit will be as well. Okay, well, I hope you did okay on those. And I hope that they work well to serve as a model for your homework for tomorrow. Thanks for joining me. Have a great day.